Hello friends, this is Ishant on behalf of Edureka. So today we are going to see sorting and searching in arrays. So there are various different algorithms through which we can sort the elements in an array, and same way we can even do searching. Now typically when you are in an e-commerce shopping website, let's say Amazon or any other e-commerce, so you want to sort the items on the basis of the price, right? So that's like either ascending way or the descending way. So one of the practical usages where you can actually apply these sorting algorithms. So these are some commonly used algorithms, and they have their own, time and space complexities, but we are not going to discuss that in detail here. So we'll typically see how they work and how we're gonna solve this problem to sort the data in an array. So we got bubble sort, selection sort, insertion sort, quick sort, and merge sort as algorithms, which we are going to discuss for the day. So let's begin with bubble sort. So guys, given the sorting techniques, so when it comes to the bubble sort, it's one of the simplest sorting algorithm, right? So what it's gonna do is it's gonna perform the swapping of the adjacent elements in case they are in a wrong order, right? So we're gonna always swap the adjacent elements if they are in a wrong order. So we are considering that we're gonna sort the array elements in an ascending arrangement. So let us see how it's gonna work. So consider that we got set of elements as 4, 1, 10, -3, and 12. So what bubble sort will do? So in case of bubble sort, so we'll start one of the iteration. So consider the ith iteration. So we'll start from the 0th index and we'll compare the index 0 with the index 0 plus 1. That's like 4 and 1 we are going to compare here. So when we compare, we find that 4 is greater than 1. So we swap the elements. Now the next is where we are comparing 4 and 10. So 4 and 10 will pass because 4 is lesser than 10. Then we'll move on to the next adjacent elements, that's like 10 and -3. So when we compared them, we found that -3 is a smaller one, so we swap them. And same way when we compare 10 and 12, so it's perfectly fine. So let's pass. Now in the next iteration, so we'll again begin and we'll now start from the next index of the ith loop. So here now we'll see -3 and 4 has been swapped, and thereafter we'll compare 4 and 10, and finally guys, the last iteration, so on and so forth, will finally sort the array. So what we are doing, we are just comparing the adjacent elements. So if one is found to be lesser than the other, so you swap them, right? So let's try to write a small code snippet on bubble sort and see how it's gonna work for us. So I'll write one small program here. So let's create a new class. So I'll say a bubble sort with the main method. So considering that we got the elements of an array, so let us take the same use case. So 4, 1, 10, -3, and 12. So this is the input sequence, right? So this is something which we are looking forward to sort. Now, in order to sort, I'll write one method here. So let's say this goes like static void. I'm just gonna say sort here. So I'll take array as input. So the array which I want to sort, and here will come up and say bubble sort dot sort the ARR. So you're passing by reference. It means that if you sort this reference, right, so automatically this will be sorted. So it's basically reference concept which we are using here. So the first thing first, so I'm going to now calculate the length of the array. So let's say length is ARR dot length. So this is the size of array more or less, right? So we'll run one loop. So this is, let's say, the outer loop which starts from 0, and this loop shall go till less than your length -1, and thereafter I'll say an I plus plus. So it means that this loop will go from 0. So this I loop's gonna work from the 0 index, then 1, then 2, and then 3, right? Not the last one, right? So it's less than length -1, right? So if the length of my array is 5, So let's say the length is 5. So the outer loop here shall work from 0 to 3. So it's length minus 1. So we want to iterate till here. Now I'll have one more loop. So let's say this is the J loop. So J loops begin with 0 and J loop will run from 0 to length minus of I and minus of 1, and then I'm gonna say J plus plus. It means the jth loop is dependent on the ith value. So if the I value is 0, consider that if I is 0, so your j will vary from 0 to, now length minus I minus 1, right? So what is the length? Length is 5 minus 0 minus 1, that's like 0 to 4. So on and so forth, it's gonna work for the other indexes of I. Now let us compare in case the ARR's jth index is greater than ARR's j plus 1 index, right? So if the element is greater, we are checking for the adjacent elements. Now if the adjacent elements are being compared and we find that ARR j is the greater guy, so we'll swap it, right? And we'll use the swapping technique as a very basic swapping technique. So we'll have a temporary variable in which I'm gonna put this jth element, and thereafter we'll have ARR's jth element allocated with the ARR j plus 1, and lastly we'll have ARR j plus 1 having the 10. So I'll just write down here, swap the adjacent elements, and this is how our logic's gonna work, right? So we keep on swapping, and once this entire swapping is done, the loops are terminated, so you will get one sorted arrangement of your elements. So when you say bubble sort dot sort the ARR, so now if you say for loop, let's say int element in the ARR, so I'll simply CSO and I'll say element with some space. So you run the code here as Java application. So what you see is the sorted arrangement of your array, -3, 1, 4, 10, and 12. So this is the very first and the very basic technique called bubble sort. So we compare the adjacent elements and we swap them. So guys, let's move next. So for our next sorting algorithm, we got something known as selection sort. So guys, selection sort is also one of the sorting algorithms, and here this guy will sort an array by finding the minimum element and putting it to the beginning. So we'll keep on repeatedly doing these steps. We'll find the minimum element repeatedly and we'll just place it in the beginning of the array. So that is how our selection sort is going to work, right? So let us understand this. So when we are in the first iteration, so we exactly are trying to see the minimum number, and we will find that -3 is the minimum number in the first iteration. So we'll put it in the beginning. Now we'll shift the next index and we'll just keep on comparing, and we'll see that 1 is the shortest one, so let it be there. So thereafter we'll move the index to the next position and we'll see now who is the other small element. We'll find that 4 is the small element. We'll now come up and put it in the beginning, and lastly we are in the sorted set, right? So selection sort is comparing the number. So we are just going to compare the number with all the elements. Wherever we find the shortest element, we put it to the beginning, right? So let us have one small program with respect to selection sort and see how it's gonna work for us. So the way we got bubble sort, I'm going to say a new class here. Let us say this goes like selection sort with the main method. So we'll take the same use case. So instead of having this bubble sort, we'll have selection sort. So I'll create a similar sort method. So let me copy this. So we'll have a similar method where we're gonna sort the data, right? So the structure begins in the same way. So the thing is, we need to come up and iterate for the same structure. We're gonna iterate from 0 to length minus 1. So the internal structure, it's gonna be a bit different now, right? So what I'll do is, I'll first of all assume that the minimum element, or you can say that minimum element on the index is the element at the ith index, right? So the minimum element, right? So I'll just write here. So assuming minimum element is at ith index. So we're assuming this part now, right? And we'll now look for any element who is a minimum than this. So for that, I'll put up a loop which starts as in j's value with I plus 1, and j shall run less than the length of the array. So we are iterating over the entire array. And if in case we say that ARR of j is less than ARR of minimum index, so considering that what we have is, we have the jth element less than the minimum index element. So what I'm gonna do is, I'm gonna say let minimum index go as j. So in the array, we are finding the minimum index, and once we got the minimum element, so our minimum index over here means, guys, we are targeting the minimum element, right? So here we are targeting the values, not the index. So we are just capturing the index of the minimum element. Now, once we captured that, so thereafter what I'm gonna do is, I'll swap the minimum element with the first element. So swap minimum element with first element. So what I'll do now is, I'll take up one temporary variable in which I'm gonna store the minimum index. So thereafter, let's have ARR of minimum index with ARR of I, and thereafter the ARR of I will be having the temporary. So this is like swapping the element and not the adjacent elements the way we had it in the bubble sort. So this is a bit different way of dealing with the things. But at the same time, when you will execute this program of yours, so what you find is the data is again sorted for us. So how these algorithms are different? So they have the different approaches to solve the same problem. So they vary in time and space complexity, of course, but that is not something which we are going to take now. So guys, this is something known as selection sort, right? So how we are selecting the element which is minimum and then putting it into the beginning. Now let us move to the next part. So guys, next part we're gonna come up and discuss something known as insertion sort. Now what is insertion sort? So when I'm talking about insertion sort, so this is very much similar when we are playing the cards. So what we do is, we pick up the smallest card and we put it in the beginning. So here we are going to work in the same way, right? So we're gonna pick an element and insert into the sorted sequence. So let's see one iteration that how insertion sort will be working for us. So for insertion sort, let us assume the same input. So when we will compare 4 and 1, so you see that over here we got 4 and 1 being compared. So we'll swap them, and now we'll move into the guy called 10, and thereafter we see that -3 is again a smaller element, so we're gonna shuffle it to the beginning. So it's just like the way you sort your cards. So finally you'll get a sorted sequence, right? So guys, insertion sort is something which is sorting the data in a different approach for us. So here we are going to again find the smallest value and swap the same, right? Let's try to write a code snippet on insertion sort and see how it's gonna work for us. So let me come here and create a new class. So this goes like insertion sort with the main method. So let me take a similar method here. So we'll call it sort itself, and coming here. So we are going to work from 0 to length. That's like 0 to 4. So we'll take the same sequence and we'll see how it's gonna work for us. So I'm gonna say insertion sort dot sort, right? So let us now write the code to sort the array. Now I'll first of all consider that there is a key which is basically ARR of I. So we are assuming that the very first index itself is a key. And I'm going to now create one j which shall be your I minus 1. So basically, I want to move the elements of the ARR from 0 to this j so that whatsoever are greater than the key to the position ahead of their current position, right? So let me write the code that's gonna be more helpful for us. So here I'll say while j is greater than and equal to 0 and ARR of j is greater than key. So run the loop till we have these conditions being satisfied, and if the loop is in execution, so what I'll do is I'll say ARR of j plus 1, you just copy the ARR of j and you decrement the value of j by 1. And once this loop is terminated, come out of the loop and we'll have j plus 1 index with the key. So that is how we are sorting the array over here, guys. So in order to sort, what we are doing over here is we are moving elements of ARR from 0 to I minus 1, right? But we are moving only those elements which are greater than key. And where we are moving? So we are moving them to one position ahead of their current position. So if the current position is j, we are moving it to j plus 1, exactly the way we do it in the cards, right? So you're just moving them one position. So guys, now let us try to run the same code and see what happens for the sorting technique over here. So what we see is insertion sort has also sorted the array and the technique is modified, but the outcome still remains the same. So insertion sort in action. So guys, once now we have since understood what is insertion sort, so we'll be now moving into the other algorithm called quick sort. Quick sort is not as in that it's really a quicker algorithm to sort the elements, but when it compares itself to the merge sort, yes, it is quicker. So what exactly happens in the quick sort algorithm? So guys, it's a divide and conquer algorithm. So what we do is we partition our array and then we try to solve the problem. So consider the set of elements 9, 5, 4, 1, 7, 2, 3, and 6. So what we try to do over here is we will decide one of the elements in this array which can be serving as a pivot or a pivot. So the pivot element is the element which can be either the first element, the last element, or the middle element, or any random element of your choice. So it can be any element. Now the whole idea is to choose this pivot element and break your array in such a way that all the elements left to the pivot should be less than or equal to it, and the right to the same pivot we should have greater than elements. So we are going to make our pivot to go into the exact position. So this way we will be coming up and sorting up the entire array. So shifting the pivot to the right position will be our key success. Now consider 6 is the pivot number from the entire list of sequence. Now consider the ith index or the ith variable and a jth variable. So the variable j will be iterating over the array and we will be comparing each and every element to the pivot that's like 6. So considering when your j is 0, that's like the number 9. So we're gonna compare 6 and 9. So we know that when you compare the number 6 and 9, So 9 is greater than 6, right? So we are okay to go with it. Now we increment the j and we bring it to the 5. When you compare 5 and 6, we find that this jth element is less than the pivot. So whosoever is less, it should move in the beginning or to the left. So what we are going to do is, if we find the element lesser than the pivot, we are going to move it to the beginning, or we are just going to swap number 9 and number 5. And now I am again reiterating on the jth index, and I have incremented the I index as well. So let's say initially I was pointing to this guy 5, but when we did a swap on 9 and 5, we incremented the variable I as well. Now the new number with the jth index is 4. So if you compare 6 and 4, so we understood that 4 is lesser than 6. So what we'll be doing is, we will be re-swapping your number 9 and 4 and then increment I. Now again 6 and 1 there compared, and we see that 1 is less, so you again swap. But 7 is greater, you don't swap. But 2 is what, which we know is lesser. So what we're gonna do is, we're gonna swap your 2 with the 9. So on and so forth. So lastly, what you will have is, you'll have the elements that's like 5, 4, 1, 2 and 3, which are lesser than the 6, and 9 and 7 greater than the 6. So we get this 6 exactly positioned after 3 and before 9, right? So guys, that is how we are doing this partition, and then we are sorting the structure. So let's see a code snippet on quicksort. So I have this code walkthrough here. So what I have is, I have the input sequence of the same elements 9, 5, 4, 1, 7, 2, 3 and 6. So we got this sort method here, where I'm passing array, the 0th index, the length -1. So these are the initial inputs to this sort method. So here we are with the sort method. So if you got low less than the high, which exactly it is, so we are going to call the method partition with the array low and high. Now partition method is working in the same way. So we are considering the pivot as the last index. So high means the last index, the last element. Now index of the smaller element shall be low -1. So that's like we are creating this variable I, and we are iterating in the jth loop, which will iterate in the entire array. So if the arrj is less than the pivot, we are going to swap arri and arrj, and we'll also increment the variable I. And finally, once you are done with everything, so what we're gonna do is, we're gonna move our pivot to the right place. So eventually entire array to the left of pivot should be less or equal, and to the right will be greater. So putting the pivot to the correct position. That is what we did in this partition method. So recursively, we are going to sort it, and till time we don't get the correct elements in the list, we keep on sorting them. So when we run this code, quicksort.sort, and you see we will have the elements in the correct order. That's like 1, 2, 3, 4, 5, 6, 7, and 9. So this is what we got as in quicksort, guys, right? So guys, now let's have look at the other algorithm for sorting, that's like the merge sort. Now merge sort is also a divide and conquer algorithmic approach. So what we're gonna do is, we're gonna divide the array in two halves, right? So you say it as left and the right one. So here what we will be doing is, we'll take one example of the same sequence 4, 1, 10, -3 and 12. So we're gonna divide this array into two different halves. So once you divide the array, so you keep on dividing the array further. So you see, once you are dividing the array, you divide till we got all the single individual elements. And once we have all the single individual elements, right, so thereafter we'll start working on merging these arrays, right? So here guys, we'll write something known as a merge function, which will merge the two halves based on which is greater, which is smaller. So what we're gonna do is we're gonna merge first of all 1 and 4. We'll see that 1 is smaller number, so we're gonna place it first and then we're gonna bring it 4, right? So on and so forth, we keep on merging the elements, and we'll first of all finish the merge on the left array, then we'll finish the merge on the right array, and lastly we're gonna merge left and right array both, which will be the sorted arrangement at the end. So in this merge sort algorithm, divide the arrays into two sub arrays, left and right. So thereafter you sort the arrays at the end, right? So let's have a quick look on how this algorithm can work for us. So I already have the code snippet for this. So let me just open it. So here we are. So now typically for a merge sort algorithm, how it's gonna work is, so we got this function called merge, and I'm gonna take the same sequence of inputs. So that's like 4, 1, 10, minus 3 and 12. So just give me a moment. So 4, 1, 10, minus 3 and 12, right? So what we are doing here, let's see now. So we got this guy called merge as one method, which is supposed to merge two arrays. And if you will see over here, we got sort, which is going to sort the two arrays, and thereafter it's gonna merge. So I'm going to initiate my program by executing the sort method, right? So for the sort method, I am passing array to be sorted. I'm passing the lower index, that's like 0, and I'm passing the higher index, that's like your length minus 1. So this 0th index and this guy is the 4th index. Now in case L is less than R, which it is, so we are going to come up and say, let us find the mid L plus R by 2, and we now calling the sort method twice. The first sort happens on the ARR L comma M. The second sort happens on M plus 1 and R, right? So once we sort the left and the right part, then we are going to merge both of them. So over here, when I'm doing a sorting, so you need to understand that it's a recursive call. So we are calling the method again and again until this condition is satisfied. So what happens in the merge part? So here what we see is we got two different sizes, right? So S1 and S2 are the two different sizes for the arrays. So we are creating the left array and the right array based on two different sizes. So the left and the right array size. So what I do is I copy the elements in the left array and in the right array. So this is merge over here method. So this is going to merge two arrays which we partitioned, and you got LARR, which will be working from your L to M, and we have this guy called, let's say, RARR. So there is subarray 1 and subarray 2, right? So I'll just say ARR 1 and this guy ARR 2. So the second array is going to work from M plus 1 till R. Now we are copying the elements here. So create subarrays. So this is like create subarrays, and here what we are doing is we are copying elements into subarrays. And now once you have copied the elements, so we'll start the process of merging, right? So let's say start merging process here. Now in the merging process, so what we got is we got indexes for the first and the second array. So I'll take the 0th index to be the initial index. And once I have taken that, so I'll take the initial index of merged sub array. So that's like K is L. Now while your I is less than the S1 and J is less than S2, so what we will be doing is we'll be further checking if I index in the left is less than or equal to. If it is so, we're gonna assign the ARR's kth index with the ith index in the left array, and then you increment the I. Other way around, it's the right array which has to be considered. So till I will be less than S1, we are going to come up and copy the ith index in the left array into the kth index, and then you increment the I and the K. So lastly guys, if the J index is less than S2, you do it for the same part, but you are doing it in the right array. So we got something known as merge process and we got something known as sort process. So when you run this code here, so eventually you will again get the sorted outcome. So guys, sorting can work in various different ways. So we got this technique called merge sort where you keep on dividing the array and thereafter once you have individual elements you start the merging sequence. So this is the final outcome that how we gonna work with it. Next part is how we are going to search in the arrays. The first one is a linear search. So what we're gonna do is we're gonna identify an element that whether it is there in the array or not. So we'll begin from the 0th index, we'll keep on advancing till the last index. So once the element is found, we get to know the index, which index it is, and thereafter we return back the index. So in the linear search operation, so we get to see that there are few inputs to the method. So we're gonna return the index of the element which is found, right? So considering the use case, right? So we are planning to have this linear search. So we'll write one small program. Let's have it with the main method. So I'm going to take the same sequence of inputs which we have been following. So this is the array, and let's say the element which you want to search is the number 10, whether the 10 is there or not. So I'll write down this static int search, or let's say this is linear search. So in the linear search, I'll pass one array and element which I want to search, right? So this is how we are going to come up with the linear search approach. So we'll get to find the index. So by default, I'm keeping the value of index as -1 and I will return the index at the end. Now you just say for int I is 0, I less than the ARR dot length and I plus plus, right? So you are iterating in the entire array. So less than length is your n. Now if element is going to match the ARR of I, right? So if it is going to match the ARR of I, so I'm gonna say index is I and thereafter I'm going to break the loop. So now you come here and say int found index is linear search dot linear search array and the element 10. We know where is the 10 element, right? The 10 element is at 0, 1 and 2, second index. So let us say if I is not equal to -1, we'll find the element and so this guy is found index. So let's say if the found index is not less than, not equal to -1. So we got the element. In the else case, I'll say so element plus element not found. Or the other way around, I'll say so element plus the element found at plus the found index. So this is what we got. So now when you run this code here, so it says element 10 found at 2 index, right? So it's the second index where you have this element 10. Let's say this guy has 12, you run the code, it's gonna say at 4 index, but if you try to enter something like 120, so you gonna get element 120 not found. So guys, linear search algorithm is where you begin from the 0th index and you keep on comparing till the last index, right? So the next searching technique over here with us is binary search. So in the binary search, what we're gonna do is we're gonna sort the array first, right? So we should have a sorted set of array. And when you are going to find the element, so you are dividing this array into two parts. So we're gonna divide the array as in the left side and the right side. So if you are finding some array in the binary search, right? So this is now very much simple approach what we did in a linear search, but the only thing is this, we'll be searching the element into a corresponding half. So we keep on dividing the array to find the element. Okay, so now let's say you wanna find this element number 79. So what we are going to do is we are going to take the right part of the array so as to search that element. We will not iterate into the lower half. And into the upper half also we'll keep on dividing the array again and again. So let's try to write a binary search algorithm and see how we can do a small search operation. So this is basically gonna save the time. So this is optimized on time complexity. So let me write a new class, and this goes like binary search with the main method. So similar to your linear search, I'll just have this. So this is what we got over here as, let's say, static int binary search. So I'm gonna take array as input, then I'm gonna take something like left, something like right, and the last one is, let's say, the element x, so which you are going to search. Now the guy over here is gonna check whether r is greater than or equal to L. So if r is greater than equal to L, then we're gonna find the mid. So the mid goes like L plus r minus L divided by 2. So we got the mid part, and now so I'll use recursive technique over here. So in case, so let's say if element is found at the same middle index, so I'll just keep a check that if ARR of mid is equal to this guy called X, then you just return this guy called mid. So I'll return the middle index itself, right? Now there can be the other possible use cases. So let's say if element is smaller than the middle, in case element is smaller than the middle, so it means what? Hence element shall be present in the left part of array. So element would be there in the left array, and hence what I'll do is I'll just put up a small condition that in case ARR of mid is greater than the X, the element which we are going to found, so here I will again do the binary search. So I'm gonna do again the binary search, but to do the binary search now, so I'll go with mid minus 1, and I'm finding the same guy X, right? So we are finding the same guy X over here. And lastly, guys, so I'm gonna say return me. So return me a binary search of ARR, your mid plus 1, right, and X. So else the element will only be available in the right part of array. So this is the case where element shall be present in the right part of array. So if it is in the left, so you execute this, so return from here, else you come, if this condition fails, we're gonna return this part. And let's say if we reach to a stage where element is not at all available, right? So if the element is not present, then what? Then you should return -1. So let's try to come and say return of -1. So here I'm gonna perform a binary search called binary search, and you need to make sure that the array is in a sorted arrangement, right? So we'll say this array over here. So you need to sort this array first. So what I can do is I can just make it -3, 1, 4, 10, and 12, right? So that's like the precondition. Array must be sorted first. Now when your array is sorted, so let's say you need to find the element called 4, and in the binary search you pass the ARR, that's like the first thing, then you pass your 0th index. So guys, let me just take some more inputs here. So let's say the length is ARR dot length. So this is the length of the ARR, and I'll pass length -1 and the element which I want to search. So we are searching for this guy called 4. let's give a small run on this and let's try to see what happens. So it says element 4 found at second index. Let's search for 12. It says at fourth index, and when I say 120, you give a run here, it says 120 not found. So guys, this is a binary search operation. You keep on dividing your array into sub arrays to the left and to the right, and then follow that array in which your element would be present, right? So greater than or less than condition check. So this is a recursion approach through which we are solving this binary search problem. So this is what we have over here as in the binary search part. So this is all from my side for the day. So guys, thank you so very much, and I hope you enjoyed the session. Bye bye guys, and do subscribe to our YouTube channel and like our Facebook page. Thank you guys. Bye bye.